Hi, I'm Glenn.
And I'm Brent.
And we're the Penumbra Brothers.
We focus on you.
This is Glenn from the Penumbra Brothers. Welcome back to our series on the ARRT exam content specifications. Today specifically we're going to cover X-ray beam A, B, and D. There's a C in there, but we're going to cover that in a different video. So we're going to cover the X-ray beam, its frequency, wavelength, beam characteristics, and the fundamental properties of X-rays. The frequency is how many times the crest of the waveform passes a specific point per milliseconds. X-rays normally run from about 5 to 30 billion cycles per nanosecond. So that's a lot of cycles. Wavelength itself is the measurement from one crest to the next crest. In X-rays, that normally runs from about 0.01 to 0.1 nanometers. A pretty short distance. The beam characteristics are quality or penetrating ability of the beam, the quantity or intensity of the beam, and then whether we're talking about primary or remnant. The quality or penetrating ability of the beam is controlled by kVp and also filtration. So the higher the kVp, the higher the penetrating ability or the more power. It does not change velocity, but it only changes the penetrating ability of the beam. Now, filtration affects your overall energy of the beam by eliminating those low energy photons, increasing the average power of the beam, but not raising the maximum power of the beam. I kind of look at it like a baseball player. If he throws 3 100-mile-an-hour fastballs, 3 90-mile-an-hour fastballs, and 3 80-mile-an-hour fastballs, the average speed is 90. Now, if we filter out or eliminate those 3 80-mile-an-hour fastballs, now our average speed is 95. It works the same with radiation. The quantity of the beam is controlled primarily by mass, or that's the primary control, is MA in time, so the amount of milliamps that go to the filament, and then how long we apply that current. kVp also controls primarily the quality, but it also does have a significant effect on quantity of the beam as well. And the other, of course, is SID. Like with the inverse square law, direct square law, the closer you get, the more intense the beam is. The further away from the X-ray tube to the detector, the less intense the beam is. So the last one is the difference between primary and remnant radiation. The primary beam is what's coming out of the X-ray tube directed towards the patient. The remnant beam is once the beam goes through the patient, there's a certain amount that is absorbed or turned into secondary and scatter radiation. That part being eliminated is our remnant beam that's going from the patient to the detector. And the last section of this is the X-ray beam fundamental properties. So there's a lot of fundamental properties. They have a short wavelength. They travel in straight lines at the speed of light, which is 186,282 miles per second. Now, they do travel in that waveform, but they do travel in a straight line, and that waveform does not expand with distance. It stays in that tight waveform. They have no mass. They are pure energy, so there's no weight to them. They can penetrate matter, obviously. That's why they work for us. They cannot be detected in any way by human senses. They're electrically neutral, so they don't have a positive or negative charge. They can cause harmful biological effects. This is primarily in the form of like a single or double strand break in a DNA. They can cause ionization, meaning they can liberate an electron from an existing atom of whatever tissue it happens to be passing through. They can cause secondary and scatter radiation. A lot of times that's within the patient, and when that happens, it is, of course, a much lower energy photon. They cannot be refracted or reflected like light. That is the difference in light and X-rays is that penetrating capability. They are polyenergetic, which is a lot of different energies in that primary beam. And they also can cause fluorescence of certain crystals. Back when we were using film, that was how we exposed the film. And that is our section on the X-ray beam parts A, B, and D.